So this is part 2 of the static routing chapter, which is module 15 in the CCNA2 curriculum. In the previous section, we looked at static routes and how to configure static routes. In this one, we're going to look at some other types of static routes, starting with default static route. A default static route is configured a little bit different than a traditional static route because a traditional static route would be looking for a specific address, specific information, whereas a default static route is a more general route. It actually matches all packets. Some people refer to this as a catch-all route, or it's often referred to as the gateway of last resort, and you might see that listed in your routing table. They're commonly used when you have a device that's referred to as your edge router or the router that's connected to your ISP. You might use a default route. Okay. So going out to your edge device, or if you only have one route into a network, you might want to use a default route. It's really easy to configure. So for a default static route, it's IP route quad 0, what we call quad 0, which is 0.0.0.0. The mask is actually 0.0.0.0, and then either the next hop address or the exit interface. Same thing with IPv6, except for there's much less typing with your IPv6 addresses because you can abbreviate the zeros with : : /0. So in this case, we're in R1 and we want to just tell all traffic to go to 2.2, the 172.2.2. And really that's the case in this scenario. If anything is coming from here, it would need to go there anyway, whether you're going to this network, or this network. So you can configure a default route. The command is IP route 0.0.0.0.0.0.0, and then 172.16.2.2 would point it to the next hop address. If you're configuring with IPv6, it's IPv6 route : :/0, and then the next hop address. You verify this the same way that you would your other static routes using your show commands. You'll see it listed as the gateway of last resort is this. So 172.16.2.2 to get to that network. And you will see it listed as an S with an asterisk. And you see up here in your code, that's the default route. Again, the S is an indication of a static route. Same thing with your version 6. So that's a pretty easy one to configure. Now, another type of route is a floating static route. So think about in a scenario of having a default route with a, with a dynamic route. So you're looking at dynamic routing tables. Dynamic routing tables are built based on different dynamic routing protocols. You can have EIGRP or OSPF. Those would be your two main routing protocols. EIGRP was proprietary till a few years ago. It is made more public, but we still tend to think of that as proprietary. The majority of the protocol was made public. There are still a few things that are reserved for proprietary use, but OSPF has always been able to be used with Cisco and non-Cisco devices. So that one is used real world, for example. Now, the administrative distance for OSPF is 110. EIGRP, the administrative distance is 90. If you'll remember from the previous video when I talked about your administrative distance, the administrative distance is the trustworthiness of a route. So the lower the administrative distance, the more trustworthy it is. Well, say you're configuring EIGRP and the administrative distance is 90, but you want to have a backup just in case your routing protocol goes down for whatever reason. Well, if you'll remember, static routes have an administrative distance of 1. So if you go in and configure this as a backup, well, then the router is going to use the one with the lowest administrative distance, which would be the static route. but you don't want that. So what you can do is configure a floating static route, but change the administrative distance to 91. So EIGRP uses 90. Change your administrative distance on your static route to 91 so that the dynamic routing protocol is used first. If it goes down, then it will use the floating static route. So to configure that, you would configure IP route, quad zeros, then next hop address, and then you would configure 5, for example. Or you would configure 91 if that was actually being used for a backup to your dynamic route. Okay, so that was configured, and then they're testing that out. So what they did was issue a shut or shutdown in interface. Okay, so they changed that to down, and they were trying to see if the traffic pattern would change. So you see the S indicated here with the asterisk for a static route, and you see the administrative distances of 5 instead of 1. So you actually have a chance to try this on this exercise here, which is 15.4.4. So I would definitely recommend doing that. Now, what we actually looked at was a router. So in addition to a router, hosts also have a routing table, and you can see those in a router as well. I'm sorry, on the device itself, but it looks like here we're looking at this branch server. So what they're actually looking at here is active interfaces on a router. When a router is configured, by default, you will have the C's and the L's indicated within the routing table. The C's indicate the network itself, which would be here, and then the L would indicate the actual address, the IP address of the link. Those are automatically created whether you're looking at version 4 or version 6. In this scenario here, the branch device knows how to reach this network, but they don't know how to reach over here to the server. So if you enter the command IP route 209.165.200.238, it's mask, okay, and then you enter in the next hop address. So it would need to go from the branch server to the ISP router. You can verify it using the show IP route, or if you're looking at version 6, you can do that show IP route, show IPv6 route. In this one, so say we accidentally make a mistake, or you want to take out the one that was configured, you can do a no IPv6 route. So you can use issue the same command that you did. I think the easiest way to do this is to use the up arrow, because your command buffer holds the last 10 commands that you've entered. And just use the same command and type a no in front of that, and then you can type the next command here. So they removed it and then typed the next one. So it looks like what they did was, instead of using the other interface, they used the link local address here as the next hop. So you do have a packet tracer and a lab. The lab will let you practice configuring all the static routes. These are very important concepts, because not only will you use these here within this module, but you will also use static routes and configure those along with your routing protocols. And you will use these in the CCNA2 course, as well as if you were to take any other CCNP classes and other networking classes as well. Static routes are used. This is a real-world scenario where you would use your static routes in addition to dynamic routes, because dynamic routes exchange information with each other, which means that all of that information would be shared, anything within the dynamic routing protocol. So there might be cases that you don't want some information shared with another routing protocol, wanting provide a little bit more security. So that would be a case where you would use static routing. So both dynamic and static routes are used in today's network. It's a good idea to make sure you have an understanding of those concepts. Again, not only for this module, but for future sections, future topics that you'll be learning within the CCNA curriculum.